Today in this session, I would like to introduce Mr. Madhu Parvathaneni, Madblock Technologies Strategist, who is currently working in Hyderabad, India. Today, he will be talking us about and enlightening us all about the programming with the Solidity. Now, before he starts, let me introduce you. He's a mentor for change at ATAL Innovation Mission since April 2018 in Hyderabad, Telangana, India. He's a founder of ORL Makers in Hyderabad. He's also the founder of Orange Research Labs. He did his BTech in ECE with first class with distinction from Padma Shri Dr. B.V. Raju Institute of Technology. So today he will be giving the depth knowledge of the Solidity. So I kindly invite him. Sir, the time is all yours. Hello. Sir, am I audible?
Hello, yeah.
Yes, Kanika audible.
Okay.
Amitji, give the control to Madhu.
The ATAL FDP session on Solidity programming. I was very grateful to be here to deliver my talk on Solidity programming. So before I get into this, let me share all this, okay? I did all this from my GitHub. You can download the PPT. A repository called GKV Haridwar Solidity. So in that Git, you can able to find my presentation with respect to Solidity programming files. Okay, so this is a link, github.com/madblocksgit. So in that Madblocks Git, you can able to see a repository called GKV Haridwar Solidity session. Can I share this link in the chat so that you can directly take this?
Yes, sir. That would be great, sir.
Okay. The link in that, you can click on that. You can able to find my PDF and also my programming files, so that you can also see those things and you can get started. So let me jump back. So I'm the data strategist working at Madblock Technologies Private Limited from the last 10-11 years. So also working on blockchain. So I started working on blockchain for the last 2.5 years. So this is my mobile number 7. If you have any queries, so this is my WhatsApp number also. Drop a message, or you can mail me on mad@madblocks.tech. So in the agenda of this session, I will be talking about what is Solidity, what is this programming language, and what are the data types and operators. Because for any programming language, we need a data type, right? So we need to store some data and the variables, and we need to understand what kind of data types are there. And also we need to understand what kind of operators are there. And then I'll be talking about functions and function calls, so function modifiers and all. So, and the fourth part, I'll be talking about how to use inheritance and how to use exceptions and all. Because tomorrow I'll be talking about how to build a decentralized application on the Solidity programming language. So if you could understand this kind of syntaxes today, so tomorrow the building of the decentralized application project will be a bit easy for you. Okay. So into the today's part, what is Solidity? So I guess the blockchain, everything was introduced in the ATAL FDP program today. So let me skip all these slides because you are aware of it. Blockchain, Bitcoin, and Ethereum. So when Solidity programming language is concerned, so it's a programming language required to create a smart contract. So smart contracts are available on Ethereum blockchain network. Hope you're aware of it. And let me skip all the slides. Let me jump into the smart contracts here. So because Solidity is mainly used to create a programmable contract which can be deployed on the Ethereum blockchain network. So smart contracts are self-executable based on the programming logic which is written on the contract, and it is also used to automate some kind of business logic that is deployed on the decentralized network of a blockchain, mainly on Ethereum. So if you're good at writing a smart contract on the Ethereum blockchain network, these kind of contracts are also available in other blockchain platforms also. So this is very good start. If you understand how to write a smart contract, then obviously you can develop various kinds of applications related to various blockchain platforms here. And when you look at a smart contract, what is a smart contract and why you need it? A smart contract is needed today because to eradicate a third person between the entities here. So if you have a two parties, first party and second party, if you want to sell a land agreement, so generally these days people go to an agency, right? So when people go to an agency, the agency people will be taking some commission fee, and and they'll be searching for a seller and buyer there, and the transaction will happen through an agency, right? So when you have a smart contract which is deployed in the blockchain network, whenever the party, obviously the land agreement will be converted on the name of the buyer, and this kind of transactions can be made automatically when you put a smart contract in between the parties there. For example, say when you look into Amazon or Flipkart, so these days Amazon and Flipkart are not on a blockchain applications, right? So when you look at Amazon, say if you purchase a phone on Amazon, what happens that you have to pay money, or you have to put some cash on deliveries and all, right? So above cash on delivery, let us understand, let us have a scenario like, you have paid some money onto the product which is purchased on Amazon. Then what happens that you have to pay money through a bank account, right? So the bank account, the amount will be debited from the bank account, and that money will be, sent to the Amazon, and Amazon will be taking some commission fee, and and that amount will be sent to the vendor. Once the vendor receives the amount, he started packing the product, and that product will be delivered to you. So when in this process of supply chain, if you look at, there are some malfunctions happen. Sometimes sometimes you get a product which is which is not opted, and sometimes you get a damaged product. Sometimes instead of product you get some stones, something like that. If you look at this kind of scenario that is happening in the real time sense, then obviously when you bring smart contract on the Amazon platform, on the Amazon e-commerce platform, wherein if you get a good product, then only the smart contract will be executing, will be sending money to the Amazon, and once the money is received by Amazon, so that money will be sent to the vendor there, which means that vendor will be more responsible when the money is being deployed, when the money is getting through a smart contract, because smart contract always is a self-executable, right? No one can control it. So in the blockchain application, you don't have any owners. Everything is decentralized. Everything is distributed across the network. And once if the Amazon is having a blockchain, architecture which is deployed on it, so whenever you order a product, your money will be, deployed, will be stored on the blockchain network through a cryptocurrency, wherein in the smart contract you have an option, you have a programming business logic, wherein whenever you get a good product, whenever you get undamaged and proper product, then only the smart contract will be allowing the cryptocurrency to be delivered to the Amazon, and the Amazon, once it receives the cryptocurrency, the amount debited to the vendor there. So when you have this kind of process, vendors, the delivery boys, everyone will be more responsible for delivering the good product there. So these kind of smart contracts are coming up in the blockchain networks to eradicate the third party, to have a more trust between the entities, because no one can store the data on the smart contract. Once the data is stored on the blockchain network, no one can store, no one can tamper it, and no agents are required in between the parties. So you can have a you can communicate with the communicate with the second party directly, and it's difficult to hack. So safety and security is there, and efficiency. So efficiency is also very important. So it's a lot of time. So in order to have a smart contract on the blockchain network here, so you need a program, because smart contract is all writing programming logic, writing a business, converting your business logic into a programming logic, so that the smart contracts can able to understand what kind of logic is written on that. So you need a programming language in order to write that programming logic on on the smart contract, which can be deployed on the Ethereum blockchain. And that programming language is called Solidity. So Solidity is an open source object oriented programming language which is used to write smart contracts on Ethereum blockchain. And Solidity is influenced by C++, Python, and JavaScript. If you're good at one object oriented programming language, you can easily understand Solidity. In the next 1.5 hours, I will be showing you various kinds of syntaxes in Solidity programming language. It looks very familiar, because if you're at C++, or if you're good at Python, or if you're good at JavaScript, you can easily understand what are the syntaxes and all. And it's a very good start today in this ATAL FDP program. And you know what Solidity, so if you have a programming language, obviously you need a compiler, right? Because Solidity is a high level programming language, and you need a compiler which converts that high level programming language into a bytecode. So bytecode will be, you know, executed by Ethereum virtual machine, and then that bytecode will be deployed onto the blockchain network here. So you have a compiler called Solidity compiler, and Solidity compiler converting that high level programming logic into a bytecode, and that bytecode will be deployed on EVM. So and you know that will be deployed onto the blockchain network by using Solidity, I know, compilers and all. And also you have a compiler called Solidity compiler, you have a programming language called Solidity programming language, but you need an IDE, right? So you need an IDE in order to write a program. So the popular IDE for writing smart contracts, for writing Solidity, you know, particular Solidity is Remix IDE. So Remix is a open source tool that helps you to write smart contracts or Solidity contracts straight away from the browser. No need to write, no need to install any tool as of now. You can directly use Remix engine on the web browser, and you can start writing your smart contracts on the browser itself. And so this Remix engine supports, you know, both browser, and also you can also install this Remix on your laptop on the you know, and also you can run your programs there. But as of now in the today's session, I'm using Remix engine, which is a browser based IDE as of now. So I'll be using this. So Remix engine is used to debug your smart contract. It is also used to deploy your smart contract. So since it has three features now, so this is very cool. Let's jump into the Remix engine. Let me show you what is in the when you talk about options in Remix. So there are three. Is called File Explorer. So what is File Explorer? File Explorer is about a file manager which manages all the files that get stored in the, you know, Remix IDE. You having a Solidity compiler. So Solidity compiler available on Remix IDE is available in different versions. So so this is an option available on the Remix IDE to compile the Solidity. And if the program has any errors, it will display all kinds of errors on the file potential there. And also you will be having deploy and run. So you can easily deploy your smart contract and you can able to run it. So you can able to execute the smart contract directly from the web browser. And you know, IDE, since I say, you know, Remix engine is a web-based browser, web-based IDE. So you can access through remix.ethereum.org. So this is a web-based IDE. So you can easily write some Solidity syntaxes today in this session. So let me you know, let me show you that. So let me open a browser. Let me open this remix.ethereum.org. Let me share the link in the get started. Is my voice user to write smart contracts on the web browser IDE. So let me use this Remix IDE in order to create some kind of you know, the smart contracts. IDE, you can able to see File Explorer, which is selected. In the File Explorer, you can able to see some kind of Solidity files which are already written there. And you will have the second option called compiler. Okay, so you will have a compiler here. So it was not loaded completely. One second, let me reload the page. So I'll be using this remix ID for creating the smart contract. So let me jump into the Solidity programming. Okay. So this is a remix ID. You can jump into this URL remix.ethereum.org. So by using this remix.ethereum.org, today I'm just demonstrating the Solidity syntaxes on the programming language here. So let me jump into the presentation for a while and let me what kind of data types are available. Okay, data types and what kind of syntaxes are there to include a data type and all. Let me discuss all that. So before we get into the the Solidity programming syntaxes, so as I said, Solidity is available in different versions. So before we create a smart contract in the Solidity file, so what we have to do is we have to discuss about, we have to talk about what kind of compiler version has to be included for compiling this smart contract file. So here Pragma is a keyword in a Solidity programming language that enables certain compilation features, because when you look at a Solidity compiler, it is available in different versions. In each version you have a different syntax, okay, altogether. So in the recent version, you'll have multiple libraries included and multiple keywords included there. But when you look into this Solidity compiler with first version, so you may not have that kind of features there. So that is why if you want to compile a Solidity contract, you have to talk about what kind of compiler version you have to include it here. For example, say if you want to include a compiler version of 0.6.6, what you have to write is pragma space Solidity space 0.6.6 semicolon. So every statement, if you look at in C or C++, every statement will be ending with semicolon, right? So here also in Solidity, so majority of the statements are ended with a semicolon. Pragma keyword which is written in the Solidity programming language to understand. So pragma is a directive here. What kind of directive it is? It is telling the compiler that you have to include this version. Okay, so it is telling the IDE to include this version of compiler which is 0.6.6 semicolon. So then the syntaxes which we write in the smart contract will be compiled by the compiler version of 0.6.6 semicolon here. When you look at the next point which is related to programming language is comments, right? So comments are programmer friendly. So comments are the Solidity also supports two types of. One is like single line comment, second one is multiple line comment, the same as C or C++. In C programming language you will have single line comment as // so multiple line comment, if you see in C you will have / multiple lines. So this is syntax in Solidity programming language also. And when you look at data type is very, very important, because we need to understand what kind of what type of data that we want to store in the variable. So if you look at variables, variable is nothing but an identifier which stores value, right? So we need to talk about data before we talk about variables here. And there are 6 different types of data types available in the Solidity programming language. One is Boolean. Boolean, hope you're aware of true or false, right? So you will have a Boolean data type with a keyword called bool. And we have an unsigned integer ranging from unsigned int 8 to unsigned int 256, which is nothing but, when you talk about unsigned int 8, so 8 bits of memory will be allocated. When you talk about unsigned int 16, 16 bits of memory will be allocated. And when you talk about unsigned int 256, 256 bits of memory will be allocated here. So when you write unsigned int, so it is nothing but unsigned int 256 here. So we have unsigned integer, we have signed integer. So you have int 8 to int 256. So int 8 is nothing but 8 bits of memory will be allocated. When you talk about int 256, 256 bits of memory will be allocated. Int and fixed point numbers, you have floating point number. Floating point numbers are called fixed point numbers. When numbers, it's assigned numbers there. Fixed m by n, where m is nothing but m number of bits will be allocated in terms of memory. N is nothing but n number of decimal points here. For example, when you talk about fixed point, fixed 8 by 1, which is nothing but 8 bits of memory will be allocated, and 1 decimal point it will consider there. M by n, m is nothing but bits, n is nothing but decimal points. M should be always divisible by 8, and it should be ranges in between 8 to 256. And when you talk about n decimal points, n should be in the range of 0 to 80. So Unsigned fixed numbers are nothing but, these are the unsigned floating point values here. You have a fixed keyword called u fixed m by n, which is nothing but u fixed m is m in the range of 8 to 256. N should be in the range of 0 to 80. So, and this is the fifth data type available in Solidity programming language. And you have a data type called address. So if you want to store a wallet address, you have a crypto wallets, right? In blockchain, if you want to make some transaction, so you will be having some wallet address. So you have a data type called address. So this is used to store 20 byte value. So 20 byte memory will be allocated for address data type here. And this address is used to store the wallet address or the account address in this data type. So you have the 6 fundamental data types available in the Solidity programming language. You have Boolean to store Boolean values. You have unsigned integer to store unsigned integer values. You have signed integer to store signed integer. Fixed point numbers to store a floating point values. But here you have a data type, have a keyword called fixed m by n, where m is nothing but the number of bits that has to be allocated, because data type will always talks about how much memory it has to be allocated. So that is why here you have in terms of memory bits here. So, and you unsigned fixed point numbers, you have u fixed m by n, and address, you have address data type here. And when you're talking about variable, because when when you understand data type and variable, you can jump into the writing a program, right? Because data types and variables are very important. So when you talk about variable, what is variable in any programming language? Variable is an identifier store a value. So you will have 3 kinds of variables here. One is called state variable, and one is called local variable, and one is called global variable. What is state variable? State variable is a variable where you can access within the smart contract. And the memory allocation, when you talk about memory allocation, the memory will be stored in the contract storage. So the memory allocation will be in the contract storage here. So whenever you deploy a contract, a memory will be allocated for contract, and in that memory, so this variable memory allocation will also goes there, and they are called as state variables there. And local variables are nothing but variables within the function. So sometimes there will be kind of variables where you declare a local variable within the function. So whenever the compiler comes out of the function, you don't have that scope, right? So you have local variables. And global variables are nothing but variables which are accessible through the entire blockchain. So you have global variables. So something like message.sender, or you'll have block ID, or you'll have block transaction there. So all these are the global variables where you can access and through the entire blockchain. And you have these 3 kinds of variables. One is state variables, local variables, and global variables. So in a C programming language or C++ programming language, you have 4 kinds of things here. One is called variable declaration, and one is called variable definition. Variable definition is about understanding what value that can accommodate. And when you talk about this kind of value can be accommodated, then obviously memory will be allocated there in variable definition stage. And in the variable initialization, declaration and definition will be done at the same instant. That is called variable initialization in any programming language. And when you look at variable assignment, value will be assigned to it. So you have 4 kinds of operations on variables. Variable declaration will be there, variable definition will be there, variable initialization will be there, and variable assignment will be there. And when you talk about scope of the variables, you have 3 types of scopes in terms of variables there. Local variable scope lies within the function, whereas a state variable scopes are of following. So you have a public variable, so public scope. So when you have public scope, both internal and external access through the various calls is possible there. When you have internal scope, so when you write internal keyword, then only within the contract or within the derived contract, so you can access those kind of variables. When you put private, only internal access within the contract, so can be accessible on the contract there. And when you talk about syntax, so data type, hope you're aware of it. In the previous slide, we discussed about various kinds of data types available in the Solidity programming language. And we have a scope. We have 3 types of scope. One is public, internal, and private. So after that, you have to talk about variable name. So in any programming language, you have some rules of putting some variable names, right? So here also you have the similar rules here. So data type space, scope space, variable name. So when you talk about data type, there are plenty of data types available in Solidity. And you have scope, you have public scope, you have internal scope, you have private scope. When you talk about public, so both internal and external access will be there. And when you talk about internal access, only within the contract or derived contract, sometimes you have parent contract, sometimes you have a child contract, sometimes you have a third party contract which is written on the same Solidity file. So internal is nothing but only within the contract and also within the derived contract. And when you look at private scope, so only within the contract will be there. So the scope will be limited when you look at private scope there. And when you look at operators, so there are different types of operators, say something like, arithmetic operators, which is like, addition, subtraction, multiplication, division, modulus division, increment and decrement operators will also be there. And when you look at comparison operators, hope you're aware of it, not equal to, double equal to, greater than, less than, greater than or equal to, less than or equal to. Logical operators, when you look at logical operators, you have logical and logical or and logical not. Same as your C programming operators. Bitwise operators, you have bitwise and bitwise or, bitwise not, bitwise exclusive or, and you have bitwise left shift and bitwise right shift, same as C bitwise operators. And when you look at assignment operators, you have equal to, plus equal to, minus equal to, which is like compound assignment, star equal to, slash equal to, modulus equal to. So these are the assignment operators here. And you have conditional operators. So conditional operator in the sense you have question mark and colon. So in C programming language also you have this conditional operators. So these are the 6 types of operators available in the Solidity programming language, because Solidity programming language is created by taking C++ as a reference there. So that is why you have similar kind of operators on C++ also. The same operators will reflect on Solidity programming language. And when you look at loop, so you have 3 kinds of loops here. One is like, you have a decision making also, that I will discuss in the next slide. But here when you talk about loop, it's an iterative loops, right? So you have while loop, you have do while loop, you have for loop here. And when you look at loop control, sometimes you write break keyword, sometimes you write a continue keyword, sometimes you write a pass keyword, right? So hope you're aware of how to use break, how to use continue, and how to use pass and all. And while loop, it follows similar syntax like C programming language. And when you look at do while, so it also follows a similar syntax. When you look at for loop, it also follows a similar syntax. And when you look at decision making, you have 3 kinds of decision making branch statements here. One is like if statement. So one is like if else. So you have if else if. So similar to C programming language. So, and when you talk about the the derived data type, which is like strings. So strings are supported in Solidity programming language. So you have a keyword called string space variable name equal to value assignment. So in strings, people talk about carriage return, people talk about new line, people talk about tab space, people talk about hexadecimal value. So hexadecimal value is very important in smart contracts, because most of the cryptographic hashes will be converted into hexadecimal value. So hexadecimal value is something like /x and tab space /t. So these are the escape sequences available in the strings in Solidity programming language, same as your C. And when you look at arrays, so arrays are a collection of values of similar data type, same as your C programming language. You can access the members of the array through the index, same as C. Index value always start with 0, and you can also create static arrays and also dynamic arrays here. And when you look at the syntax of creating a static array, which is like unsigned int. So when you write unsigned int, which is nothing but unsigned in 256 bits. So 256 into 3. So because the size of the array is 3. So for A array, so 256 into 3 bits will be allocated as a memory part. So unsigned int of 3, which means that the size of the array is 3 and a variable is A. So A is an array which is holding 3 values here called 1, 2, 3, which is included in square bracket there. So this is an array, same as your C programming language. Array is nothing but a collection of values. And when you look at enumerated data type, this is also available in C programming language. And here the values of enumerated list are called enums. So say you have a syntax like enum space the enumerated name, which is like Madhu, and flower bracket open the enumerated list values here, which is like orange, mango, and apple. So when you talk about enumerated, so the value, so these are nothing but the every index, every value will be having some enumerated names here. When you have an order like orange, mango, apple, so you have for orange you have 0, for mango you have 1, for apple you have 2, something like when you check at the syntax here, Madhu space ms. So which is nothing but Madhu is an enumerated data type, so which is created, which is defined here, and we have a variable called ms. So to this ms we can assign enumerated value. So if you assign Madhu.orange, so the value of ms will be 0. When you assign Madhu.mango, the value will be 1 will be assigned to ms. When you assign Madhu.apple, so 2 will be assigned to ms. So you have enumerated data type in and Solidity programming language, and you have a collection, the second collection which is available in the Solidity structures. Structures is also a collection of values of different data types. So you have a structure, so struct abc, so the flower bracket open, you have string a, so which is of string data type, unsigned int b, which is of unsigned int data type, and you can easily access the members of the structure through a structure variable. And the structure variable you can easily access by using dot operator, same as your C programming language. So where you can access through dot operator, you can assign a value, and you can, so structure, so it's a collection of variables of different data types. So it is similar to C programming language. And when you look at the denomination of ethers, because one ether is almost 28,000 rupees as of now. So it's so whenever you make a transaction in Ethereum blockchain network, so you will be doing on V's. So 1 V is equal to 1, and 1 Sasbu equal to 1 into 10 power 12 V's, and 1 Finny equal to 1 into 10 power 15 V's, and 1 Ether equal to 1 into 10 power 18 V's. So this is a denomination, something like 1 rupee equal to 100 pies. In the similar way, you have 1 Ether equal to 1 into 10 power 18 V's. So let me show you all this in the remix engine for a while, so that you guys can understand how to write a Solidity programming language here. So I have shared the, I don't know whether I'm audible or not. I have shared the GitHub link, right? So you can also go through that. So it has a lot of Solidity examples which I have wrote for the FDP session. So write a simple, program in order to show you how to use, the syntaxes into the program. So let me create a new file. Am I audible?
Yes, you are audible, sir.
Okay. So you have different Solidity files here. Okay, so let me show you how to use this Solidity syntax in the remix engine, so that you can also get started with me. Okay, so let me create a new file. So let me click on plus. So in File Explorer, you have this options plus. So let me click on plus. So when you click on plus, you can able to see the menu which is asking to create a new file with some file name. So Solidity files extensions are .sol. So that is most important. So in the place of untitled, let me write, ATAL FDP, program one, whatever. So ATAL FDP underscore 1.sol. Let me click on OK. So when I click on OK, you can able to see, the text editor here. Okay, so here what we have to do, so let me write a simple program, so which is like addition of two numbers. Okay, to understand how to put your Solidity syntax into the logic. So here addition of two numbers. So here what I wanted to do is I wanted to pass two arguments. Okay, so I wanted to pass user input. I wanted to pass user input, say 2,3. So I wanted to return a result. Okay, I wanted to return a result. So I wanted to store this result. I wanted to store this result in the state variable. So what is state variable? State variable is nothing but the memory will be allocated in the contract storage. So I wanted to take user input. So who is user? User is nothing but who is accessing the smart contract. So here you have two people, right? One is owner and second one is user. So user can be owner sometimes, or user can be a third party person, right? So owner and user. So user input, I wanted to read input from user, which is like 2,3, and I wanted to store this result in the state variable, and I wanted to return this result. Okay, whenever you call it. Okay, so I want to return a result of some So whenever you invoke a function call, okay, so I wanted to do this, I wanted to put this logic into the Solidity, okay, syntaxes and all. So here what I wanted to do is, so here if before we create a contract, you have to tell the Solidity compiler that, you know, I am using this respective version, okay, because in each version you have a different syntaxes. So let me go for pragma space Solidity space. Say you have a version, like you can take any version, so it's up to you. So let me take a version like 0.6.6. So pragma space Solidity space 0.6.6. Okay, so it is so we are giving a hint to the compiler saying that, you know, you have to consider this version which is like 0.6.6. So here let me show you how to create a contract. If you want to create a contract space some contract name. So let me define the contract as some underscore ATAL, or you can say some ATAL FDP. Okay. So let me create a contract. So now it's easy to create a contract which is nothing but contract space name of the contract flower bracket open and close. So this is how you need to create a contract. Now here, what is your target? Your target is to, write, is to read the data from user, and you wanted to store that result in the state variable, isn't it? So here what we have to do, let's take a state variable. State variables are nothing but variables where the memory will be allocated in the contract storage. So let me take the data type called unsigned int. Okay, when you write unsigned int, which is nothing but unsigned int 256. So 256 bits of memory will be allocated here. Let me put the scope as private. So when you write private, only within the contract, so this fellow can be accessed. So let me write a variable called sum. So we have unsigned private sum. So here sum is a state variable. So here sum is a state variable. Sum is a state variable, and it is having private access. So only the members of this contract can able to access sum. So outside members cannot access this sum variable. So which is like private scope. And here what I have to do is I have to read data from user. If you want to read data from user, every logic, okay, you have to be programmed through a function. So through a function call here. So what we have to do is we have to define the function. Okay, so function space. So we have to define the function. So if you want to define the function in Solidity, you have to start with a keyword called function. Then only the compiler will be understanding that, okay, this is a function definition. Okay, function space. So get values. Okay, say function name. So here, what is your task? Your task is to read data from user. So we have two values here, 2, 3. And these 2, 3, I wanted to read data from user, say get values of. So what are 2, 3? So they are of integer data type, right? So let me take unsigned int A, unsigned int B. So I wanted to take two arguments. Okay, one is called unsigned int A, and the second argument is called unsigned int B. So to this A, B, I can pass 2, 3. So unsigned int A and unsigned int B are local variables, right? So they can access only within the function. So let me define the function here. So let me put it public access, okay, because the third person can able to access this from outside the contract. So whenever you deploy this contract onto the blockchain network, so people can access get values function because I made it public access here. So public is nothing but the scope of the function. So people can able to access from outside the blockchain network. So from outside the contract, you can able to access this function, which is called get values of unsigned int A, unsigned int B. Okay, so here let me calculate the sum value. So let me write sum equal to A plus B semicolon. So when you write sum equal to A plus B, okay, so when you write sum equal to A plus B, so A value will be read from user, B value will be read from user. The addition I'm storing in the sum, which is a state variable here. So this function will calculate the sum. Will calculate the addition of two numbers. That value I'm storing in some variable here. And let me take one more function. So function space, show result. Okay, show result. So no need to pass any argument. Let me put it public access here. But this fellow is returning the result value, right? So when it is returning the result value, so you need to specify the returns keyword here. In the returns keyword, you need to mention the data type that it is returning. So it is returning unsigned int. So unsigned int. So let me return the value called return sum. So I wanted to return sum whenever you invoke this function. So here there are two functions here. One is like, get values, and second one is show result. So this both are public functions. One is having argument. So the second function is not having any argument. And this first function is not having any return value. So that is why there is no returns keyword here. But the second function, if you see, it is having a return keyword. So that is why I have used a keyword called returns. I'm just intimating the compiler that yes, I'm passing some, return value of this data type. So I'm passing the, some variable. So some variable is nothing but unsigned integer data type. So that is why I have mentioned it as unsigned int. Okay. So this is how you need to put all your syntax. Okay. But you have, you have the function scope. Let me show you that. Okay. So let me save this file. So any doubts in the program? Can you, any doubts? You can ask me. You can able to see my screen, right? So the first one is file explorer on the left side, and the second one will be the compiler version. Okay. So as I said, your Solidity is compilers are available in different versions. So I'm using 0.6.6. So you can also use the latest version. So only the syntaxes will get different there. So as of now, I'm using 0.6.6. So let me put it auto compile. Okay. So when it is auto compile, so no need to compile it again and again. Automatically the program will be compiled. If there is any error, that it will show in the console. Okay. So let me put it auto compile. So for the first time, let me compile the program. So whenever I compile the program, if there is an error, it will show the error. So declaration error. Acha, unsigned int is UINT. Okay. And there is a so there is one more warning. So it is showing. So it is asking to put mutable. Okay, because here we are not doing any kind of changing the values, right? So here in this function we are updating the value of state variable, but here in this function we are not updating any value. So that is why it is asking to put restricted access to view. So that let me put a keyword called view. So when you put a keyword called view, so this function will be restricted to view only. So you cannot do any kind of operation inside the function. So that is for security. So this is like, mutable. So only view, you can view the, values that comes from the function here. So these are the modifications which are done according to the compiler suggestion. So now the program is compiled. So it is auto compiled. So you can able to see a tick marks. When you see a green tick mark, which means that it is compiled successfully. Let me deploy this. Okay. So we have a contract called some ATAL FDP, and we have some variables here, which is state variable. And we have two functions here. One is called get values and show result. So these two functions are in public access, so people can access outside the contract. So here, this function, you can assign two values, a comma b. So let me deploy it. So to deploy this, let me jump to, the third option here, which is like, deploy and run. So as I said, you will have file explorer, you will have compiler, Solidity compiler in the second option. In the third option, you'll have deploy and run. So as of now, let me use JavaScript virtual machine. Okay. So this will this is an environment where you can deploy your smart contracts for test purposes. So once the smart contract is working good, you can also integrate your smart contracts to your Ethereum networks. So in Ethereum network, you will have main Ethereum network, you will have test Ethereum networks. Anyways, I guess in the afternoon, we will be showing you how to deploy to the Ethereum network. As of now, let me jump into JavaScript virtual machine. So in the JavaScript virtual machine, there are 10 different accounts which are holding some test ethers, which are like 100 ethers. So every account is having some address, which is like, 20 byte address will be there. So let me select one account. So in Ethereum, so people have discussed this. So there will be a gas, so which is like a transaction fee. So because whenever if you want to deploy a smart contract, you have to pay a transaction fee. So that transaction fee will be collected through a gas. So we have to put some limit. whenever if you want to deploy a smart contract here. And here, what is a contract name? The contract name is some ATAL FDP. You can able to see that. So that contract I wanted to deploy. So let me click on deploy. So whenever I click on deploy, so it pushes to the blockchain network. In the blockchain networks, miner has to mine the transaction. So what is a transaction here? Deploying the smart contract is a transaction. So miner will be doing it, will be mining the transaction there. And once our transaction is done, a block will be added to the blockchain. So here, since it is virtual machine, so it will be done in seconds, but in the real-time scenario, it will take some time in order to mine the transaction. So and also it is also based on the amount of gas that you keep for a transaction fee. If the amount of gas is more, the time taken to mine the transaction will be taking less, because miner will be understanding that, so they will be they'll be opting the the transaction which is having high transaction fee. So like that, the transaction will happen. And you can able to see a tick mark. So when you see a tick mark, it means that the transaction is done. Okay, you can able to execute, you can able to test those smart contracts here. So you can able to see deployed contracts in the same window. So in this deployed contracts, you can see some ATAL FDP is deployed, and it is having some contract address. So this is the contract address. So when you click on this, you can able to see the two function buttons here. One is called get values. So we have written a function called get values, and we have written a function called show result. So let me pass two arguments here, say 2, 3. Let me click on get values. When I click on get values, it will send a request to the the network. So so it is calling some ATAL FDP.get values. So transaction request is being sent, and that is being mined automatically by the the JavaScript virtual machine. So auto mining is happening here. So it is being done in seconds. And let me click on show result. When I click on show result, you can able to see the result is 5. So let me update the values to 20, 30. When you click on get values, again it will send a request to the blockchain network. The transaction will happen there. Once a transaction is happened, then obviously you can able to click on show result. You can able to see the new updated value here, which means that this functions, this smart contract functions can be accessible from outside the contract. So whenever if you want to make if you want to call this function, you need to call them with the smart contract address. So here you can able to see the smart contract, because rather than smart contract name, a unique address will be assigned to the smart contract once you deploy it on the network. So by using the smart contract address, so we will be accessing the contract, but on the remix IDE, it is calling. So this address will be called on the back end, but in the front end, it will be displaying the contract name. But in the real-time scenario, two contracts can have same name. So there is a chance of having two contracts with same name, but no, the address will be different for them. So we will be accessing through the contract address, so that it will be easy for us to handle the contract functions here. So here there are two contract functions. One is called get value. Second one is called show result. So like this, you need to call them through the contract. So each and every time you need to compile your Solidity program. And once a Solidity program is compiled, then obviously you can easily deploy it on the test networks, or you can deploy it on the JavaScript virtual machine. So if you see here, the amount of ethers are also reduced. So amount of ethers, so initially it was 100 ethers. Now you can able to see 99.99 and so on, because the transaction fee is very less, because 1 ether is almost 1 into 10 power 18 Vs. So the amount of transaction will be deducted in terms of Vs. So that is why you can able to see some floating point value here. So this is the balance which has been displaying here. So as of now I'm using the same account address for making some transactions here. So whenever you make a transaction, this address will be selected. So based on this address, the amount of fee will be deducted on it. So let me write another program. So this is like hello world program. So every program, every programming language will have an hello world program. So here also this is a simple program where you can understand how to declare a variable, how to define a variable, how to put access to that. And also you will be understanding how to read data from user, because user is a third party person, right? So the user can be owner, or user can be a person who can who is accessing the smart contract here. Any doubts here? which has been deployed. So let me use the same contract name. Okay. So let me remove all this stuff. So let me write a simple program. Okay. So now the agenda of this program, let me have the agenda of this program is to use while loop. Okay. So while loop and if loop, whatever. Okay. While loop and if loop. Let me write a simple Solidity program, but which does a task like, the sum of all the digits of a given number. Okay. So let me, I wanted to familiarize, the logic so that you can put it into the Solidity syntaxes and all. Sum of all the digits of a given number, I want to demonstrate how to use while loop and if loop also. Okay. So let me take a state variable. Okay. So this time, let me take a state variable to public access. Okay. So unsigned public, say a variable called sum. Okay. So initially, let me initialize it to 0. Okay. Unsigned int public sum equal to 0. Okay. So this is a result variable, right? So because I wanted to calculate sum of all the digits of a given number, unsigned int public sum equal to 0. So let me take data from user. Let me have a private variable unsigned int private. Say, let me take one variable called num. Okay. So this is a private variable. So both are state variables, right? So this is a public state variable. This is a public state variable. So this variable can be accessed outside the contract. This is a private state variable. Okay. So here, let me define a function. So to read the data from user, let me write function space get data from user. Okay. So get data from user. So what data I want to read unsigned int, say a. Okay. So I wanted to give public scope. So here I wanted to read data from user. So let me assign that value to num. Okay. So num equal to a. So the value will be assigned to num, right? So after that, let me define one more function to calculate the sum of all the digits of a given number. Let me write function space computation. So let me have. Okay, let me don't have any return value or arguments here. Okay, let me put it private. Okay, I want to define private function. So computation. So computation is a function definition. It's a computation is a function name defining a function, which is computation here. So here, what I want to do is I want to perform the operation called sum of all the digits of a given number, where num is a private state variable. So I can access inside the computation function because computation is a part of the contract, isn't it? So here, let me use the variable called num inside the computation function. Let me use a simple logic like while. Okay. So while loop. So in while, let me put a condition here, which is like, num not equal to 0. Okay. Num not equal to 0 is like, it's a comparison operator, right? So you have num not equal to 0. So here inside that, let me extract the last digit because I want to split the number into digits so that digit by digit I can add up, right? So let me have sum plus equal to num percentile 10. Okay. Sum plus equal to num percentile 10. So what is num percentile 10? So let have num value be 1, 2, 3, 4 for understanding, or 1, 2, 3, something like that. So 1, 2, 3 is not equal to 0, right? 1, 2, 3 is not equal to 0, which is obviously true. So 1, 2, 3 percentile 10. So 1, 2, 3 percentile 10 is nothing but 3. The initial value of sum is 0. Initially some value is 0, 0 plus 3. So 3 will be added here. And num equal to num by 10. So what is num by 10 here? Num by 10 is nothing but 123 by 10. So 123 by 10 is nothing but 12.3. So 12 will be taken because it's unsigned int. So 12 not equal to 0 again. So 12 not equal to 0 is true. So 12 percentile 10. What is 12 percentile 10? So 12 percentile 10 is nothing but 2. But in the previous iteration, sum value is 3. So 2 plus 3, sum will become 5. Now the sum value is 5. And then 12 by 10. So 12 by 10 is nothing but 1. So 1 again not equal to 0 is true. And initial value in the previous iteration, some value is 5. So 5 plus 1 percentile 10, which is nothing but 5 plus 1, it becomes 6. So 1 by 10 is nothing but 0. So 0 not equal to 0 is false. immediately it comes out of the while. So here we have the sum value as 6 because 1 plus 2 plus 3 is nothing but 6 here. Okay. Now let me have a function. Okay. Anyways, we have a public value, right? So we can access the sum value directly. Okay. So let me deploy this contract. So let me deploy this contract. So we have a public function get data, which is a public function. We have some value which is public again. Okay. Let me have the one more function, or let me call the function here. Okay. So let me call the computation here. So let me define, let me have a function call. So this function computation will be nothing but function call, right? So this is nothing but function call. So that will be calling the computation function, which is defined in the contract. So in the computation function, so I written a simple logic to calculate sum of all the digits by using different types of operators that what we have discussed in the presentation. So we have achieved the sum value to be 6 because after this loop, iterative loop, so the sum value will become 6 because when the number is 1, 2, 3, so that will be assigned to 6. So and public sum is public, right? So I can access sum directly from the outside the network, outside the contract. So let me deploy this. Okay. So let me deploy this contract because it's auto compiled. There is no mistake in the program. Let me deploy this contract. Now the contract has been deployed. Let me, we have two buttons here. One is like get data. So get data is a public, and we have sum because sum is also public. Remaining else are private. Let me pass a number like 1, 2, 3. Get data. So that when you click on get data, it will send a transaction request to the network, and miner will mine it, and that value will be stored in a variable called num. So that's a state variable there. Now the computation will also happen, right? Because get data function is assigning a value to num, and also computation has been happening out there because we have a function call. Let me click on sum. So when I click on sum, you can able to see the value as 6 because we have assigned a value called 1, 2, 3. So let me assign a value like 1, 2, 3, 4 again. So immediately what will happen? The sum value will be updated, right? Because 1, 2, 3, 4. I guess sum value will be updated to 16 because yes, sum is not initialized to 0. Sum you should assign to 0, otherwise to the previous sum it will keep added there. So let me click on delete and let me deploy it again. Here sum value has to be 0, otherwise to the previous sum it keeps adding there. So 1, 2, 3. When let me click on data. So you'll get the sum value to be 1 plus 2 plus 3, which is 6. When you click on sum, you'll get 6. And when you update a new value, get data 1, 2, 3, 4, 1 plus 2 plus 3 plus 4 is about 10, right? So when you click on that, you'll get 10. But in the previous thing, we got 16, right? Because in the previous case, the sum value is 6, 6 plus 10, it becomes 16. So that is why you have to make it sum value to be 0. So thereby, the new sum will be calculated there. So this is how a loop is used, and this is how a function call can be can be called inside the contract. So that is what I wanted to demonstrate. So this is a second program. Okay, so show the remaining programs I've given in the Git, so you can also test them. So whenever you have free time, you can easily do that. So let me talk about the function modifiers also. Okay, let me show you a simple use case around the function modifier. So because that is more important, because when the contract is deployed on the blockchain network, anyone can access if they have the contract address, right? So because blockchain is open source, Ethereum, when you look at Ethereum, so this contract has been deployed on the Ethereum blockchain network. So whenever the contract is deployed, it is open to everyone. When the contract is open to everyone, anyone can access the functions, right? Because they're public. So you have a public functions, you have a public variables which are defined in the contract. So anyone can access, right? So if you want to put, the only owner has to automate or only owner has to call, then the function modifiers plays a vital role. So let me show you how to use a function modifier. Okay, say let me write another program. Okay, let me delete this. So all these programs are available in the Git. Okay, so that is why I'm not storing any files here. Oh, something is deleted. Okay, let me delete only the logic which is written inside the contract. Okay, so here let me have a simple logic. Okay, let me let me take a string value. Okay, so string space private space a. Okay, whatever, string space private space a. Now I'm taking string data type here. So let me have a constructor object. Okay, so let me take a constructor object. So what is this constructor object? Whenever you deploy this contract on the inside onto the blockchain network, so this constructor will be called automatically. So here inside the contract, inside the constructor, what I'll do is I'll store the owner's address. So I want to store the owner's address. Who is owner? The person who is deploying this contract. Who is owner here? The person who is deploying the contract is nothing but owner. So I will declare a variable called owner, okay, by using a data type called address space owner. So address is a built-in data type, as I said in the presentation also. So address space owner. So owner is the variable here. So I want to store the owner's address in the owner variable. So there is a global variables, right? So there are global variables where the variable can be accessed across the blockchain and across the different types of contracts across the blockchain network here. So let me store the owner's address by using a global variable called msd.sender. msd.sender is nothing but who is accessing your contract. Okay, msd.sender is nothing but the sender address. So what is sender address here? Sender address is nothing but wallet address. So we are able to make some transaction by using this wallet address, right? So this wallet address will be called by using msd.sender. So msd.sender is nothing but the contract, wallet address here, who is invoking the contract. So let me store it in the owner variable. Okay, so owner equal to msd.sender. There is a matter. What is that? Okay, you have to make it public. So constructor public owner equal to msd.sender, because msd.sender is a global variable there. So it is asking me to put public access. So constructor space public flower bracket open owner equal to msd.sender. What we are doing here, we are recording the owner's address and we are storing it in owner variable. So let me have a function. Okay, so let me have a function space get data. Okay, whatever it may be, get data. Let me write a string data type here, string m. Okay, let me put it public. Let me assign this value to state variable a equal to m. Function space string. When you put string, so we have to talk about memory assigned to it, because string is a is a dynamic array of characters, right? So when you put dynamic array of characters, so dynamic array is nothing but automatically memory has to be allocated based on the length of the string. So that is why in Solidity you have a keyword called memory. So memory comes in place. So here we are declaring a local variable. So whenever you declare a local variable, memory has to be allocated dynamically. So that is why I'm using a memory keyword here. So string space memory space em. So the value say will be called from outside the contract, because it is kept as a public access here. When it is in public access, so outside the contract people can access. But my point here is like only owner has to access data. Okay, no one else can able to access. That is my target. So my target here, my agenda is very simple. Only owner has to only owner has to update data. No one else. Though the contract is public. Though the contract is public. Only owner has to update the data here. Because when you keep in public, then anyone can update the value, right? So here only owner has to update the data. So here the logic is like you need a modifier, you need a constraint, you need a security to it, right? So you need a modifier which changes the behavior of the function, says that only owner has to update. So let me define a modifier. So there is a keyword called modifier. So modifier space we have to define the function modifier. So what is this function modifier? Function modifier is used to change the behavior of the function, because here it is like public function, right? So it's like public access. So when it is public access, anyone can access, right? So let me define the modifier. Say let me have a modifier name as only owner. Okay, only owner. That's a user defined name given to the function modifier. So let me define the function modifier here. So this is function modifier space only owner. That is the name. Okay, in the place of only owner, you can write anything. Okay, you can write banana, something like that. Okay, so this can be anything. Okay, so you can write banana also. So for you to understand, I'm writing only owner. Okay, that's the user defined name. So so here what I'll do is I'll use a error handling technique. So here we have to produce an error. So when to produce an error, if the owner is not accessing this, say third person is able to access your contract function, then if the third person is able to access your contract function, you have to produce an error, right? So you have to invoke an error here. So that is why there is a error handling method called require. So require is used to handle, okay, the errors here. Require. So what is require? Only owner has to access this function. So let me write owner. So owner double equal to. So I am comparing owner address with the user address. The user address will be stored in msd.sender. So whenever the user is accessing this contract, so user address will be stored in msd.sender. If that msd.sender is equal to owner address, if it is equal, then okay, so he can access the function. But here, if someone else is accessing the address contract, so we have to produce an error. So here we have to put saying that so we have to put underscore semicolon. When you put underscore semicolon, which means that the remaining logic can be executed directly. Okay, so let me put that function modifier access here only. So owner. Okay, when you put only owner function modifier here, which means that this function will be accessed only when this condition becomes true. So this function will be accessed only when this condition becomes true, which means that the execution of this function is totally based on the function modifier which is defined above. So whenever the owner is accessing this, so this becomes true. When this becomes true, then immediately the rest of the part of the function will be executed there. If this becomes false, so it will produce an error. I will demonstrate it, you will understand. So let me delete the previous contract which has been deployed, because we are using the same name to deploy it. So let me save the program and let me, there is no error. You can able to see a tick mark here. Let me deploy this contract. So the contract has been deployed. So the contract is deployed. So who is deployed this contract? So you can able to see 5b3 is address. He is the owner. Okay, I can let me pass some data here. Okay, so let me pass some data. Say ATAL FDP is going good. Say, so this is a string. Let me click on get data. So when I click on get data, so it has been updated. So there is no issue here. Okay, you cannot see the output because I have given a private access. Okay, so let me change the wallet address. So here let me say someone else. Okay, someone else is trying to access your contract. If someone else is trying to access your contract, say I say excellent. Say, then when I click on get data button, you'll get error, because you'll get error here. Get error. You can able to see cross mark. Which means that this fellow 617 is not the owner. So if it is not the owner, it is not giving permission to access the function. Okay, so you got this error. So which is like you cannot access that function, because that is this third person who is accessing your contract, which means that function modifiers will always gives that kind of scope to the function where only only respective people can able to access. Okay, say when you have 2-3 persons here, then you have to create an array. You have to store the addresses of the wallets into the array, and then only respective people can able to access your contract functions here, though they are open to public. Those open to public, so there is a constraint here. So that like this, we have to use function modifiers. So sometimes we will be using. So any doubt? Owner is not predefined name. So in the place of only owner, you can write banana also. So
Madhu sir,
repeat for a while. Let me say, so this the person who is deploying this contract will become the owner. So in the constructor object, in the constructor, what we are doing here, we are storing the owner of the contract. So owner of the contract is nothing but the person who is deploying it. So I have deployed this contract with the help of 0x5b3 account. So this 0x5b3 account will become the owner. Okay. Then we have a function modifier called only owner. So in the only owner modifier, function modifier, we are using require. So in the require, what we are doing here, we are just comparing the owner address with the user address. who is user, the person who is calling this contract. So other than owner, okay, so that will be stored in msg.sender. And if they are not equal, then obviously you will get an error. And if they're equal, though, this function will be called, okay, this function will be accessed. So that is how you need to use function modifier. So tomorrow, as we develop some projects on, the decentralized on the blockchain network, you will come across this kind of syntaxes again. So so you will understand once we start developing a project, because this is a simple example to understand how to define a function modifier. Okay, so let me jump back to the presentation. Okay, so here, as I said, so this is how you need to define function. We have used all this in the example programs. Okay, function name, function space, function name, parameters, scope, and returns. If you have a return variable, I have explained this in the example. And also function calls. So this is also I have explained. If you want to call the function name followed by parameters, so immediately function will be called. And when you look at function modifier, so it's simple, modifier space, modifier name, flower bracket open, require, and then we have to write some parameters inside. So underscore semicolon, when you put underscore semicolon, which means the rest of the statements in the function will be executed there if the condition goes true. So these are the different types of syntaxes in related to the functions. So inheritance. So we have two contracts here. So we have, as the Solidity is an object-oriented programming, you have the concept of inheritance. So inheritance is nothing but you have a parent contract and you will be having a child contract. So all the methods from parent contract can be accessible with the child contract and all. So contract A, so the contract A is a parent contract. And you can define one more contract in the same Solidity file, which is like, contract B is A. So contract B is like a child contract, which is defined for parent contract here. So there is an example in the GitHub. You can also check that. Okay. So whenever you have time, okay, you can go to that GitHub, and it is having inheritance demo program. Okay. So which is written for you to understand. You can easily understand if you're good at, the concept of inheritance in C++, because it uses the same, logic. Okay. Just go through that. Otherwise tomorrow anyways, we are having a session on decentralized applications in the project, so I'll show you that there. Okay, so let me jump back to the presentation because the time is running fast. Okay, we have error handling. As I said, error handling is also important, because when you're writing some Solidity projects or Solidity syntaxes, sometimes we need to create an error. Sometimes we need to create sometimes we need to understand how the errors are produced. So we need to handle errors. So in Solidity, we have three kinds of syntaxes. One is called asset, so and one is called require. So we have used this in in our Solidity program for in function modifiers. Require bool condition. So sometimes people mention string memory message, so sometimes people doesn't use any message. So if that message is mentioned, so that message will be popped out saying that you cannot use this. Okay, so we have three different error handling method: asset, require, and revert. So tomorrow in the projects I will be showing you how to use this error handlers in the Solidity projects. Okay, so that's all about the presentation today. So thanks for inviting me for the Solidity programming session. So thank you, sir. If you have any questions, you can drop me in the chat, or else you can interact. You can ask me tomorrow also, because I'm having 2 more sessions tomorrow. I'll just
there are certain questions in the chat, sir, if you could just answer them.
Okay.